Okay, so now we're looking at solving 2 by 2 matrices using inverses. Now, provided all products are conformable, meaning that we can multiply them, then it's possible to solve the matrix equation AX equals B using the properties of multiplicative inverses. Now, it's similar to solving something like 3x equals 7. We would divide both sides by 3. Now, you can think about that as instead of dividing both sides by 3, it's the same as multiplying both sides by 1 over 3 or the inverse of 3. So, what do I mean by that? If I have 3x equals 7, we would normally go that x is 7 over 3. That is the same as saying 1 over 3 times by 7, which is the same as saying 3 to the negative 1 times by 7. So it's the inverse of whatever is in front of the x is what we multiply by. Now, the other thing to remember is that the inverse of a matrix times by the matrix is equal to the identity matrix. Okay, so I've got AX equals B. To get x on its own, if I pre-multiply by a to the negative 1 or the inverse of a, on this left-hand side, the inverse of a times by a is just the identity matrix. So that's just x. So now let's do the same thing to our right-hand side. Now, order matters. I have to pre-multiply by the inverse of a. So it's a to the negative 1 times b. Same thing, same thing. Okay, so we have to remember that order matters. If I look at x a equals b, now the a is at the back. So to get rid of that a, I'm going to post multiply by the inverse. So therefore I need to do the same thing on the other side. So on my left-hand side, I have x times our identity is b a to the negative 1. So my x is b times the inverse of a. Now remember, this pre and post multiplying is important because matrix multiplication is not commutative. We must multiply next to the a. So in summary, provided we can find the inverse for matrix A, we can solve the equation for x. So if AX equals B, then x is the inverse of A times by B. If XA equals B, then x is B times the inverse of A. Do you need to remember these? Not really, you just need to remember the process. So remembering that the determinant of A is equal to multiplying on the diagonal 3 times 6, then subtract multiplying on the other diagonal, so 2 times 1. So that's 18 minus 2, which is 16. Now we're being asked to find the inverse of A. So the inverse of A is 1 over the determinant, so 1 over 16, and then we need to swap things around. So our 3 and 6 swap, and then our other elements just become the negative. Our next step is find x if AX equals 5672. So we need to get this x on its own, so it means we need to get rid of the a. So if we pre-multiply, the inverse of a times by ax is going to equal, do the same thing on the other side. So the inverse of a times by 5672. So that means that Ix, my identity matrix X, is going to be equal to 1 over 16. So we're just going to plug in what the inverse of A equals. So on my left-hand side, I'm just left with my X. So it's 1 over 16. Multiply your matrices. So across the row, down the column. So I've got 6 times 5 is 30. 30 minus 14 is 16. 6 times 6 is 36. 36 minus 4 is 32. Now we're doing the next row. Negative 1 times 5, negative 5 plus 21 is 16. Cross the row down the last column, we've got negative 6 plus 6 is 0. Multiplied by our scalar, our 1 over 16, that'll be 1, 2, 1, 0. And we are done. The next one is find y if ya equals that matrix. So to get that y on its own, we need to post-multiply. So ya, the inverse of a, we post-multiply it on the left, or multiply to the right, if you want to think about it that way. So we need to do the same on the right-hand side. So that leaves us with yi on the left equals, now when we're multiplying by this identity here, remember where I put the scalar doesn't matter. So I can put that 1 over 16 out the front, but I have to remember that my matrices need to go in the same order. It's easier to multiply your matrices than worry about the scalar. So I've got 1 over 16, multiply across the row down the column. Okay, so we've got 5 times 6 is 30. 30 take 6 is 24. Cross the row down the next column. 5 times negative 2 is negative 10. Negative 10 plus, a second, 5 times negative 2 is negative 10. Negative 10 plus 18 is 8. Cross the next row down the column. 6 sevens are 42. 42 minus 2 is 40. Then we go last row, last column. 7 times negative 2 is negative 14. Negative 14 plus 6 is negative 8. Bringing that scalar in, you'll have 3 over 2, 1 over 2, 5 over 2, and negative a half. Okay, in this question we have two matrices and we need to find x. So if ax equals b, we need to get that x on its own. So we need to pre-multiply. So the inverse of a times by ax, and then we pre-multiply on the other side. So we do the same thing. A to the negative 1x, or the inverse of a times a, is I. So ix equals the inverse of a times b. So that means x is the inverse of a times by b. Now we can work out what the inverse of a is. So the determinant of a is equal to 1 times by 3 minus 2 times by 0, which is 3. So a to the negative 1 is going to be 1 over 3. Swap the diagonal, change the sign. So that's our inverse. Going back to what we had, x is the inverse of a times by b. So that's 1/3. 3, negative 2, 0, 1. Then your b, 2, 5, negative 2, 1, times by the scalar last. So do the matrices first. Across the row and down the column. So that's 1/3. You have 3 times by 2 minus 2 times by negative 2. Then across the row again and down the next column, 3 times by 5 minus 2 times by 1. Next row, 0 times by 2 plus 1 times by negative 2. Next row, same row, next column, 0 times by 5 plus 1 times by 1. So that's 1/3. 6 plus 4 is 10. 15 minus 2 is 13. 0 minus 2 is negative 2. And then we have 0 plus 1 is 1. Multiplied by the scalar. So we have 10 over 3, 13 over 3, negative 2 over 3, and 1 over 3. And we are done. Let's move on to the next one. We want to get our x on its own. So now we are going to post multiply. So we do the same to the other side. A times by its inverse is going to be I. So if xi equals ba to the negative 1, so our x is ba to the negative 1. So just remember, when you have to post multiply on the left, you do the same on the right. Now we already have our inverse of a, so this is going to be 2, 5, negative 2, 1 times by 1/3, 3, negative 2, 0, 1. Now multiply it by the scalar last. Now I could have just saved that line and done this straight off. Okay, multiply your matrices first. So this becomes 1/3 and going across the row and down the column. So I've got 2 times by 3 plus 5 times by 0, 2 times by negative 2 plus 5 times by 1. Move into your next row, negative 2 times by 3 plus 1 times by 0, negative 2 times the negative 2 plus 1 times by 1. That's then 1/3. 2 times 3 plus 5 times 0 is 6. 2 times negative 2 is negative 4. Negative 4 plus 5 is 1. Negative 6 plus 0 is negative 6. 4 plus 1 is 5. So multiply by that scalar. 3rd times by 6 is 2, 1/3. 3rd times by negative 6 is negative 2, and then 5/3. Okay, remember that you could check these on your calculator. I would recommend in these cases, if you're checking on your calculator, define your variables, because you're going to keep, like, you use them in both. Okay, so it will be quicker to check. Now this is exactly the same process, but it looks a little bit different. So we just don't have our matrices defined as A and B. Process is the same though. To get rid of this matrix on my left-hand side, or alternately get x on its own, we're going to have to multiply by the inverse. So our x becomes, and it would be post-multiplying, negative 2, 0, 1, 3 times by the inverse of that matrix. Okay, now we need to work out what that inverse matrix is. So I'm going to do that off to the side. That's going to be equal to 1 over the determinant. So that's 6 plus 5. Swap the diagonal, change the sign. So that's 1 over 11, 3, negative 5, 1, 2. Come back. I'm going to put the 1 over 11 out the front. Okay, now you do your matrix multiplication. Across the row, down the column. So that'll give negative 6, 10, 6, and 1. Bring in that scalar, negative 6 over 11, 10 over 11, 6 over 11, and 1 over 11. Now for the final example, I want you to do this on your calculator. So make sure you know how to solve it on your calculator. First couple of steps that you'd need to do though is just getting that x on its own. The matrix is before it, so you're going to have to pre-multiply. So you end up with 1, 1, negative 2, 0 to the negative 1, 5 to negative 6, negative 2. So let's go to our calculator and work out what that inverse matrix is to start with. So let's find the inverse. Menu, matrix vector, create. matrix. It's a 2 by 2, and it's 1, 1, negative 2, 0. And we want the inverse of that, so the power of negative 1. So there's our inverse matrix. So now we have that x equals 0, negative a half, 1 a half, times by 5 to negative 6, negative 2. Go to our calculator again and multiply those two matrices. Now we're multiplying that inverse matrix by our other matrix. So it's another 2 by 2. Yes, you could define these matrices. I'm not going to use them again though, so I'm just entering them straight. And there's my answer, 3, 1, 2, 1. And we have 3, 1, 2, 1. Now note, you could go from this step to this step. I kind of like having intermediate steps in case I do a silly mistake. So I've got some working there to show. Now just to finish, note that matrix expressions may also be factorized if the common factor is on the same side. So what do I mean by that? XA plus XB, because the x's are both on the left, we can bring the x out the front and go A plus B. And that's going to save a lot of time because it's easier to add than multiply. In the next one, I have y times p minus q times p. So p is second. So again, I can factorize. In the third one, though, I can't because the c's at the front and then the c's at the back. So the order is different, so I can't factorize it.